Hi viewers, this session we are going to discuss about OSPF protocol implemented in multi-area network. Already we discussed on that OSPF protocol implemented in a single area. Now we are going to discuss about that multi-area network. A large autonomous system can be divided into many areas, so that administration is also very easy, and then that routing table convergence also very easy. So the the advantages of OSPF protocol is actually faster convergence than that RIP protocol, and it is scalable also, since it is divided into many small areas. We can easily scale that one, and we can do the administration well. And three type of databases are used in the OSPF protocol: neighbor table, link state database, and forward table. The forward table deals with the routing information, and the link state database deals with the topology table and the neighbor table. These are all the three different tables which are very much important for the routing the packets. And while talking about the operation of OSPF protocol, the first operation or task is actually establishment of neighbor table, exchange of link state advertisement. Okay. Next, on the building a topology table, and finally execute the SPF tree also. Okay. This is about that in the introduction of the OSPF protocol. The multi-area network. Now see this topology. Here we have 192.168.1.0 is one network, 2.0 is another one network, 3.0 is another one network, 10.0.0.0 is one more network, and finally we have 11.0.0 is another one network. So here we have a 5 network, and this 5 network is connected divided into 2 areas: area 0, area 1. So area 0 is connecting the 2 routers, in which the here 2 interfaces are there, and here 2 interfaces, and area 1 is connected with these 2 routers. So the center router is acting as a area border router. So it's a border router for area 0 and also area 1 area. So 2 areas are in this topologies. We have given 2 areas, and if you want n number of areas, more than if you want to connect one more area, you can connect here also. It can be connected with that one. And I can have another one network with 2 areas, and both can be connected with this border router. So border router of this network can be connected with the border area router of this network. The first step of implementing a routing protocol in a topology is developing a network. So here one network is developed, and it has 5 networks, and next the basic configuration to be done for every piece is connected, and the routers connected here. Next one is the configuration of OSPF protocol. So these are all the main 3 steps that we need to follow implementing a routing protocol in Cisco packet tracer. Now the topology is ready here, and the IP address for this PC is already set, So you just click on that one and the configuration window. So 192.168.1.2 is actually the IP address given to the PC. 192.168.1.0 is gateway IP address, and this IP address is given to the interface of router connected with this PC. So here 192.168.1.1 is a IP address given to, so it's act as a gateway for this PC. Similarly, the other networks also formed. So here 2.2 is actually IP address for this PC, and the gateway for this PC is 192.168.2.1, which is given to this interface. And here the next network 192.168.3.0 is the next network. So 3.2 is IP address given to this PC, and 3.1 is IP address given to this PC, and these two routers are connected with this network. Network ID is 10.0.0.0, and the IP address 1 is given to this interface. IP address 0.2 is given to this interface. Similarly, in the 11.0.0 network, 0.1 IP address is given to here, and 0.2 is given to this interface. So the configuration of PC and the configuration of router are also finished. Now we have to configure the OSPF protocol for this topology. So these are all the list of command used for implementing the OSPF protocol in this topology. Enable is the first command, and next command is config terminal. Enable command will enable the router, and the next the config terminal will change. You can change into the configuration mode by giving this command, config terminal command. Next, the setting a OSPF protocol in that router. So router, OSPF, and the process ID. We have already discussed on that process ID. Process ID is given to the process of an OSPF protocol. There are many processes used by the OSPF protocol, and the ID is given to the process used in that OSPF protocol. If now in our example we are going to give the process ID 1 for this router, process ID 2 for this router, process ID 3 for this router. So the OSPF protocol using used in this router uses process ID 1 for all its process. And the next command is network command. The network command has 3 arguments. The one argument is network ID, the second argument is the wildcard mask, and the third argument is the area number. So network ID that you know about it. Here this router is connected with 192.168.1.0 network and 10.0.0.0 this router. So this router is connecting with 2 network. This is a network ID of that network connected. And next one is actually the wildcard mask. Since it's a classful address given here, it's actually class C address, so that 256 IP addresses are available in this block. In this 256 IP address, and the first IP address is given for the network ID, and in the last IP address is given for the broadcast ID. Rest of the IP address can be given to the interfaces connected are the PC connected in that network. Now next the wildcard mask is nothing but the number of system or the computers that can be connected with the that network is called the wildcard mask. So 192.168.1.0 is class C IP address. So its mask address is 255.255.255.0 is a mask address. So the wildcard mask is nothing but the complement of this mask address. See here. Now 192.168.1.2 is actually the IP address given to the system. Since it is a class C IP address, the mask address is set to the 255.255.255.0 is a mask address. Now 255 here it means all 8 bits set to 1, and the complement of this one is 0 here, and the complement of this part this octet is also 0. The complement of this octet is actually 0. The complement of this octet is 255. So the wildcard mask of the class C subnet mask is 0.0.0.255. It means that 0 to 255 addresses can be given, that is 256 IP addresses are available in this network. So close this window. So wildcard parameter, wildcard mask is 255 sorry 0.0.0.255 for the class C address. Suppose you have given the class B IP address here, then the wildcard mask address will be the 0.0.255.255, and then the area number. So the area number for this interface is actually area 0. So these are all the 3 arguments that should be given along with this network command. And the same for example here in the network 192.168.1.0 is actually this network, and the wildcard mask address is 0.0.0.255, and in the area is actually area 0. Similarly, this router is connected with the 2 network. So one network command uses the 192.168.1.0 network. Next we have to give one more network command that uses the 10.0.0.0 network. So these are all the commands used to configure the OSPF protocol in each and every router. Once that OSPF configuration protocol configuration is finished, then we have to give a save command. We can directly give the save command from the menu itself. From the menu, you just click on that config tab and click here, then it will be automatically saved here. Otherwise we can give the command copy run start. So that command will copy the newly configured parameters into the start of a file. And the next command, these are all the commands that are all used to test the OSPF protocol. Now we can configure this router. Now configuration of router 0. Click that. Go to the CLI command. Press enter. Leave the enable command. Next give command config terminal. Now the prompt is changed into config terminal mode. Next we are going to give the router command. So the routing protocol selected here is OSPF and its process ID is 1 for this router, 2 for this router, 3 for the third router, 3 for third router. So process ID is set to 1. Next we have to give network command. Network ID is 192.168.0 is a network command. The wildcard mask is 0.0.0.255 is a wildcard parameter, and then the area is area 0. So area 0 is this interface is connected with area 0. And the next we have to configure this network. So network 10.0.0.0 is actually class A network. So the wildcard mask is actually 0.255.255.255. It's a complement of class A mask. Class A mask address is 255.0.0.0. So the complement of this one is a wildcard mask of okay. So this same wildcard mask can also be given for the classless IP address. In that cases it varies, and the area is area 0. So this router is now connected with two network, and these two networks are configured. Okay. Next we exit command. Exit. Now we will copy and start. Yes. Is saved. Okay. So so the configuration of OSPF protocol for this router is completed. Close this window. Click on the second router. Go to CLI window. Give the enable command. Give the config terminal command. Next give the router OSPF process ID 2. Next network 10.0.0.0 is one network connected with this router. So this router is connected with 10.0.0.0 network, 11.0.0 network, and 192.168.2.0 network. So this router is connected with 3 networks. So we need to configure this 3 network. So 192.10. And it's actually class A mask address, so that in the wildcard mask is 0.255.255.255 and the area is actually 0. Next we will command the network 192.168.2.0 is another one network, and it's a class C IP address, so the wildcard mask is actually 0.0.0.255. So that's also coming under the area 0. So area 0. Next command is network 11.0.0.0. the wildcard mask is 0.255.255.255 and the area is 1. Area 1. This 11.0.0 is coming under the area 1. So this router connecting the area 0 and the area 1, so that it is called as area border router. Now give the exit command, exit, and then give the copy, run, start, which will copy the configuration into startup config file. Copied. Okay. When the configuration is finished, close this window. Next to configure the third router, go to CLI window and enable, give the command config terminal command, terminal. Next give the router command, router OSPF, the process ID is 3, then give the network command. So this router is connected with two networks, 11.00 and 3.0 network, and this router is only connected with the area 1. But this router 1 is connected with the area 0 and the area 1. Router 0 is connected only with the area 0. So this router 2 is connected with the area 1 only. So network 11.0.0.0 and 0.255.255.255 and the area 1. Next network 192.168.3.0 0.0.0.255 area 1. Give the exit command, exit, and then give the copy, run, start. So file is copy, configurations are copied, close it. Now give the ping command from here, command ping to 192.168.2.2. 2.2 is actually this PC, so thinking from 1.2 to 2.2. Yes, reply is coming. Exit ping 192.168.3.2. Yes, reply is coming. So The packets are now forwarded by these three routers. Now we can give the show command. Here show IP interface brief, show IP protocol, show IP route, and show IP route OSPF protocol, show IP OSPF, show IP route OSPF, show IP OSPF neighbor. These are all the commands which is used to test the OSPF protocol in a router. So from this router you can give the command show IP interface brief. So 1.1 is one interface, 0.1 is another one interface. 1.1 is one interface, 0.1 is another one interface. So it's given here. Next, give the command show IP protocol. Yes, it uses the OSPF protocol with the process ID of 1 is shown here. And in the gateway is 1.1 is one gateway, 2.2 is actually another one gateway. The distance is given. It's called the administrative distance. Next, we will command show IP route. Yes, it shows the routing informations. So to reach the 192 sorry 10.0.0 is actually class A. So the prefix length is set to 8 and it is directly connected network. And 10.1.1.1 is a local network. Is for the local. Next 192.168 1.0 is a class C network. So the prefix length is set to the 24. Okay. So to reach the 2.0 network, the packet should be forwarded via 10.0.0.2. So to 10.0.0.2 is the IP address of this interface. So packets from this network should be forwarded through this interface for 2.0 network and 3.0 network. Okay, so it's given here. Yes, actually. So next command is show IP route OSPF. So it's also showing that in the routing information of OSPF protocol. Let's show IP OSPF. So these are all the various process or various tasks and various type of assumption made in that OSPF protocol. The link state advertisement, table of service, okay. And it is talking about that the area. Okay. Next command is actually so the neighbor table is very important table used in OSPF. So show IP OSPF neighbor. So for this router, 2.2 is actually the neighbor interface. So the neighbor ID and its interfaces are given. So this is supported that the same comments we can apply over this router and this router and check the function of the two OSPF protocol in the particular router. So this is about that the implementation of OSPF protocol in multi-area network. Thank you.